Hey guys, gonna show you some stuff I've been doing. Wow. Um, so this is a binary multiplier, 4-bit. It's pretty compact and very fast for a multiplier. I think the only other multiplier I've seen was I think it was 80 ticks, and this is about 10 or 15, so it's pretty good. And so right now I'm multiplying. Well, let's just change this. Nope. There we go. So let's multiply 3 times 3 times that one on. Yeah. Whatever, that works. 3 times 5 gives us 15. So that's pretty good. Yeah, so this didn't really take me that long, and really, I just developed the concept like today, and then I used my insta-carry adder, 4 ticks, or 4, so 4.5, maybe 5 ticks, I don't know, but this is my insta-carry adder, by the way. And basically what it does is it treats each one of these bits like if you want to multiply by, so say you have two 4-bit numbers, right? You just take one. So we use one as what you want to multiply, and then this is what you're multiplying it by. So this would say you have like this bit is the highest bit, and say then when you multiply by 8, you well, let's just start with shifting, because when you shift a number 1 over, it multiplies the number by 2. So when you multiply it by 4, then you shift it 2 over, and you multiply it by, multiply it by 2, then you shift it 1 over, multiply it by 1, you don't shift it over, multiply it by 4, you shift it over twice, and then multiplying it by, multiplying it by 8, you shift it over 3 times. And so that's basically what I've implemented, where if this bit is on, then it's adding one of these to the total output, and then if this bit is on, then it's adding 2 times that to it, and then, 2 times, 4 times, 8 times, and so it's just seeing if one of these is on, and then multiplying it by whatever number that is using shifting. I just implement shifting just by literally dragging the numbers over in the adder. And so it then adds the output of those shifters using this, and it gets the output very quickly. So, pretty proud of that. Yeah. And then this is another project I haven't really worked, it really didn't take me that long, but it's pretty cool. It's essentially a floating point adder, and what it does is it uses my shifters to place these 4 bits in one position. So say I have you know 10 or whatever in here. This input tells it where that 10 should be, or where these bits should be. So what to decide what they will represent. So you can shift them to any place on this 7-bit, well, not any place, but one of 4 places on the 7-bit input. So you can essentially expand a 6-bit input to so it can, the 6-bit input can represent higher numbers than it normally could. And then it takes it, so basically it takes the coded input and decompresses it for the adder, and then recompresses it using this little circuit, which is it's just combining outputs and stuff. And that is the placement of the bit, and then it takes the most significant bits displayed. So say you added 2 things that were on opposite sides. So one thing you were adding was 1 placed over here, and then another thing was 1 placed over here. It's just going to ignore the 1 placed over here because it's not as significant as the 1 placed over here. So because it's so small, it's really inaccurate. But it is pretty cool because it takes the 6-bit input and expands it to 7 bits. So, yeah. And then this is another thing I've been working on with grinning theirs. I'm a partner on this. That's ROM. This is another CPU I'm building, except this one is really fast and it works. Probably. It probably will turn out not to work, but whatever. This is 256 bytes of RAM, and with a 16-byte registry, a 32-byte cache, and ALU with lots of functions. Very compact comparator right there. Lots of stuff. Yeah. And right now, I am playing on the RDF server. I joined it pretty long time ago, but not too long ago. Yeah. So I'll just show you. TP. Okay. Okay, thanks, bye.